Evening, students. My today's discussion is dimensional analysis, which is a topic of chapter number 2, unit number 1. This is my lesson number 3. Here I have used some terminology in this presentation, so it is better to know about these quantities first. This first is, what is fundamental quantity? Fundamental quantities are those physical quantities that cannot be expressed in terms of other quantities. It is independent of its own, for example, mass, length, time, temperature, electric current, and there are some more, but at present we'll be learning about these 5 quantities. In this presentation, rather, we have used 3 different quantities like mass, length, and time only. The other quantities are expressed in terms of powers of m, l, and t. Now I'll talk about what is dimensional formula. Dimensional formula is an expression for the unit of physical quantity in terms of fundamental quantities. Now, dimensional analysis. What is dimensional analysis? This dimensional analysis also has got another name. It's called factor level method or the unit factor method. Is a problem solving method that uses the fact that any other number of expression can be multiplied by 1 without changing its value. It is a very useful technique. The main advantage of dimensional analysis of a problem is that it reduces the number of variables in the problem by combining dimensional variables to form non-dimensional parameters by far the simplest and most desirable method in the analysis of any physics related problem, of course engineering related problem, in direct mathematical solution. The dimensional equation have got 3 uses. Number 1 is check the correctness of a physical solution or equation, to derive the relation between different physical quantities involved in a physical phenomenon, to change from one system of unit to another system of unit. Apart from this, you can also design a new formula with the help of dimensional analysis. In this presentation, I'll talk about that. The dimensional formula, again, I want to tell you what is the dimensional formula here I'm using is a compound expression showing how and which of the fundamental quantities involved in making the physical quantity. It is about the new physical quantity we are going to define with the help of dimensional formula. Let's start with this presentation. Students, please see till the end. My first point is, what is the dimension of physical quantities? The nature of a physical quantity is described by its dimension. All the physical quantities can be expressed in terms of 7 base or fundamental quantities, namely mass, length, time, electric current, thermodynamic temperature, intensity of light, and amount of substance raised to certain powers. The dimension of a physical quantity are powers on it of the fundamental or base quantity are raised to represent that quantity. A special note, using the square bracket around a quantity means that we are dealing with the dimension of the quantity. An example, dimension of volume is within third bracket L cube. Dimension of force is within third bracket mLT to the power minus 2. The dimension of energy is ml squared t to the power minus 2. Now some dimensional quantity. Dimensional quantity is physical quantity which has dimensions. For example, speed, acceleration, momentum, torque, they all have dimension and their variables. So these are dimensional quantity or dimensional variable. Dimensionless quantity. These are variables but they don't have any dimension. For example, relative density, refractive index, strain, etc. Method of representing them as a ratio. Along with that, I can tell you that plane angle and solid angles are also dimensionless quantity or dimensionless variable. Dimensional constant. What is dimensional constant? Dimensional constant is a constant which has dimension. For example, universal gravitational constant, capital G, Planck's constant, H, Hubble constant, capital H, Stephan constant, that is sigma, Wien's constant, lambda, Boltzmann constant, K is equal to R by N, R. Universal gas constant, Faraday constant, these are all dimensional constants. So their value does not change, but their dimension is there. So they are not dimensionless quantity. And one is dimensionless constant. Dimensionless constant is a constant which has no dimension. For example, any number, it may be a decimal number, positive or negative number, e, the exponential number, and pi, that is these are all constants. I am talking about dimensional formula and dimensional equations now. The expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called dimensional formula of the given physical quantity. Example, the dimensional formula for volume, you can write it only L cube or m to the power 0 L cube t to the power 0. The dimensional formula of speed is m to the power 0 L t to the power minus 1. The dimensional formula for acceleration is m to the power 0 L t to the power minus 2. An equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of the physical quantity. Some example, let me say. Nevertheless, the same example, volume V is equal to m to the power 0 L cube t to the power 0. Velocity V is equal to m to the power 0 L t to the power minus 1. And acceleration A is equal to m to the power 0 L t to the power minus 2. In this context, I want to also mention one important thing, that the prefix does not have any meaning. Finally, the quantity determines the dimension. Like say velocity, it may be escape velocity or terminal velocity. All of them are m to the power 0 L t to the power minus 1. Similarly, acceleration. Acceleration due to a force may be there, or maybe acceleration due to gravity, or acceleration due to some other things. So it is having the same dimension, m to the power 0 L t to the power minus 2. So the prefix does not affect. Quantities having same dimensional formula, this pairs a formula, the fundamental or derived quantity, actually it is derived quantity, they have the same dimension. The impulse and momentum, work, energy, torque, moment of force, angular momentum, Planck's constant, rotational impulse, stress, pressure, modulus of elasticity, energy, density, etc. They have the same dimension. The number 5 is force constant, surface tension, surface energy. They have same dimensional formula. Angular velocity, frequency, and velocity gradient all have the same formula. Gravitational potential and latent heat, they have the same dimensional formula. Thermal capacity, entropy, universal gas constant, and Boltzmann constant, they have the same dimensional formula. Force and thrust have the same dimensional formula. Power, luminous flux, they have the same dimensional formula. So these are some of the quantities having the same type of dimensional formula. Now let us see what are their dimensional formula. So let me check some of them. Pressure, stress, elastic constant, and energy density all have dimension of m to the power 1 L to the power minus 1 t to the power minus 2. Similarly, surface tension, surface energy, spring constant have m to the power 1 L to the power 0 t to the power minus 2. Frequency, velocity gradient, angular velocity, m to the power 0 L to the power 0 t to the power minus 1. Similarly, there are many other quantities as time period,
L by R, R into C. Here L is known as inductance, R is known as resistance, and C is known as the capacity. So these are all having the same kind of dimensional formula of T. Of momentum, impulse, they have got ml to the power minus 1, angular momentum, Planck's constant, ml squared to the power minus 1, work, energy, moment, torque, heat, enthalpy, they all have the same dimensional formula. This may be a short question there. One of the quantities given and some other quantities are given. You have to match which of the quantities have the same dimensional formula as the given quantity. So this is a find objective type question. Now, dimensional analysis and its application. Dimensional analysis is a tool to find or check relation amongst the physical quantities by using their dimensions. When magnitude of two or more physical quantities are multiplied, their units should be treated as the same manner as ordinary algebraic symbol. We can cancel identical units in the numerator and denominator. Similarly, physical quantities represented by a symbol on both sides of a mathematical equation must have the same dimension. This has got a name also. This is called law of homogeneity. Dimension analysis can be used to check the dimensional consistency of equation, to convert units in one system to another system, and to derive the relation between physical quantities based on certain reasonable assumption. Apart from this, you can design a new formula too. Checking the dimensional consistency of equation, dimensional analysis first use the principle of homogeneity of dimension. In fact, these are the rules with which you will be doing the entire dimensional analysis. The principle of homogeneity, the magnitude of physical quantities may be added together or subtracted from one another only if they have the same dimension. If different dimension, you cannot add or subtract. So initial velocity can be subtracted from final velocity because they have same dimensional formula. But force and momentum cannot be added because their dimensional formula different and are mlt to the power minus 2, mlt to the power minus 1. So they cannot be added or subtracted. So let us check this one. As an example, v square is equal to u square plus twice as. The dimensions of the quantities involved in the equation are u is equal to m to the power 0 lt to the power minus 1, v is equal to m to the power 0 lt to the power minus 1, a is equal to m to the power 0 lt to the power minus 2, s equal to m to the power 0 lt to the power 0. Substitution. Now this v square equal to u square plus twice as. We saw the left hand side and the right hand side has the same dimension. So if the left hand side and right hand side of the equation is same, dimension wise, then it is a possible correct equation. Remember, here any number involved, like say here there is a 2. 2 does not have any implication in the dimension. If an equation fails the consistency test, it is proved wrong. But if it passes, it is not proved right. Thus, dimensionally correct equation need not be actually an exact equation, but a dimensionally wrong or incorrect inconsistent equation must be wrong. Example, equation v square is equal to u square plus or minus twice as. It is dimensionally correct and it is correct. But v square is equal to u square plus half as. This is also dimensionally correct, but it is an incorrect equation in mechanics. Albert Einstein tried his famous mass energy equation as E is equal to m by c square, E is equal to m square by c, and E is equal to m square c, etc. But finally settled down to E is equal to mc square using dimensions and then proved it with the help of calculus and some other methods. To check the dimensional consistency of half mv square is equal to mgh. The dimensions of the quantities involved in the equation are, first it is m, half is dimensionless constant, m is equal to m l to the power 0 t to the power 0, v m to the power 0 l t to the power minus 1. G m to the power 0 L t to the power minus 2. H m to the power 0 L t to the power 0. H is the height. Substituting the dimension in the left hand side, I got the dimension as m L square t to the power minus 2. Now you can check it out in MGH also. That is also m L square t to the power minus 2. M is the mass, G is acceleration due to gravity, and H is the height. You got the same result. So this is a dimensionally correct equation. Conversion of one unit system into another unit system. So unit derived from the dimension, and the dimension are derived from actual formula of the physical quantities. If the dimensions are known for a physical quantity, then it is easy to express it in FPS, CGS, MKS, or any new unit system. Now, in this case, you have to use one formula that is called N1 into U1 is equal to N2 into U2. U1 is the dimension of the first dimension of the quantity in the first unit system, and U2 is the dimension of the quantity in the second unit system. I replaced U1 with M1 to the power A, L1 to the power B, T1 to the power C, and U2 is equal to M2 to the power A, L2 to the power B, T2 to the power C. So in that way, by cross multiplying, you are getting N2 is equal to N1 into M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power C. N1 and N2 are the magnitudes in the respective system of units. Smaller the unit, bigger the magnitude of a physical quantity would be, and vice versa. For example, 1 meter is 100 centimeter. So centimeter is a smaller unit, so its numerical value is more. 1 Newton is equal to 10 to the power 5 dyne. Dyne is a smaller unit, and Newton is a bigger unit. So the magnitude of the quantity N is larger than that in Newton. Some examples. One question is, Joule is a unit of energy or work in SI unit system, and org is a unit in CGS. The dimensional formula of energy of the work is ml square t to the power minus 2. So units from dimension in SI and CGS units are kg meter square per second square and gram centimeter square per second square respectively. Now I'm going to change 1 joule into corresponding arc. So N1 is equal to 1 joule, N2 equal to how many arc I do not know. Mass in SI unit is 1 kg, is 1000 gram. Length 1 meter is 100 centimeter. Time is 1 second in SI unit. And CGS 1 gram, 1 centimeter, 1 second. Therefore A equal to 1, I am going to equate A equal to 1, B equal to 2, C equal to minus 2. Refer the dimension. So N2 would be equal to M1 by N1 into M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power C. Putting in the value, N2 will be equal to N1 is equal to 1, M1 is equal to 1000 gram by 1 gram, 100 centimeter by 1 centimeter, 1 second by 1 second. By solving, we get 1 joule is equal to 10 to the power 7 arc. To convert 1 Newton in a system where to mass is measured in milligram, length in kilometer, and time in minute. It's a exclusively new unit. Now here we can write Newton as kg meter per second square, and in SI unit, and the new unit system milligram kilometer per minute square. The dimensional formula is ml t to the power minus 2. So here A would be equal to 1, B equal to 1, and C equal to minus 2. SI unit system N1 is equal to 1 because that is what is asked, 1 Newton. Then mass is 1 kg, 1 meter, and 1 second length and time respectively. Now in the new unit system, mass is 1 milligram. Here you remember that a larger unit system has to be always converted into smaller unit system. It is not exactly like a rule, but it becomes easier if you convert larger unit to smaller unit. Like 1 kg is 10 to the power 6 milligram, and 1 kilometer is equal to 1000 meter. Though I have written is 1 by 1000 meter, but you can do it like this. 1 second is a smaller unit, and new unit system has got 1 minute. So 1 minute is equal to how many second? 1 minute has got 60 second. So you got N2 is equal to N1 is equal to N1 into M1 by M2, L1 by L2, T1 by T2, powers are 1, 1 and minus 2. M1 is equal to 10 to the power 6 by 1, milligram cancels out. 1 by 1000 kilometer by 1 kilometer cancels out, and SI unit system 1 second is equal to 1 by 60 minute, and so that will cancel out. So ultimately you will be getting N2 is equal to 10 to the power 6 into 10 to the minus 3 into 60 square. So it will be 3.6 into 10 to the power 6 unit. So 1 Newton is equal to 3.6 into 10 to the power 6 unit. That's a exclusive problem. So 1 Newton here is a exclusive answer we're getting. So 1 Newton is equal to 3.6 into 10 to the power 6 milligram kilometer per minute square. Deducing relation amongst the physical quantity. The method of dimension can sometimes be used to deduce relation amongst physical quantities. T is equal to 2 pi root over L by G. For this we should know the dependence of the physical quantity on other quantities and consider it as a product type of dependence. So let's see. We know that T is dependent on L and T is dependent on G. So we can write this one as T is proportional to L to the power X, M to the power Y, though mass doesn't depend on, but let us take it depends on mass also, and G, the acceleration, to the power Z. Now we have to equate the left hand side and right hand side dimension. So M is equal to M to the power M is equal to M L to the power 0 T to the power 0, L is equal to M to the power 0 L T to the power 0, G is equal to M to the power 0 L T to the power minus 2, and T is equal to M to the power 0 L to the power 0 T. Substituting, you are getting T equal to K is a constant, Lx to the power L to the power X, M to the power Y, and G to the power Z. So we have in the left hand side we got M to the power 0 L to the power 0 T, and right hand side will be getting M to the power 0 L T to the power 0 to the power X, M L to the power 0 T to the power 0 to the power Y, and M to the power 0 L T to the power minus 2 to the power Z. So you'll be getting ultimately M to the power Y L to the power X plus Z T to the minus 2Z is equal to M to the power 0 L to the power G T to the power 0 T to the power 1. So equating the powers, Y is equal to 0, X plus Z is equal to 0, and minus 2Z equal to 1. Solving, X equal to minus Z, putting the value Z is equal to minus half, we are getting X equal to plus half. So the formula takes a turn, K is equal to K into L to T equal to K into L to the power half, G to the power minus half. That is T is equal to root over K into root over L upon G. K ultimately practically can be found out as 2 pi. So this is a standard equation, T equal to 2 pi root over L over G. So this can be done by the dimensional method also. Demerit of the dimensional analysis, there is a demerit also. The dimensional analysis cannot be used for the following cases. The value of constant in an equation cannot be determined as the constant do not have any dimension. Only dimensional consistency and not the physical consistency can be tested. That means a dimensionally correct equation is not always physically correct. Dimension can be found from the physical quantity, but physical quantity cannot always be guessed from the dimension because two or more quantities may have the same dimension. The equation containing the dependency on more than 3 quantities cannot be determined only M, L, and T. Anyway, there are some systems in which the dimensions are combined. This is a special type of question that will be the level 2. I may not be talking about this type of problem in this lesson. The equation containing exponential, trigonometric, logarithm function, etc. cannot be derived as they do not have any dimension. So those quantities which do not depend on the dimension cannot be found with the help of dimensional analysis in an equation. The equation having relation other than products and quotients cannot be derived. Now there are some dimensional formula for your ready reckoner. So dimension for some physical quantities: length, mass, time, area, volume, linear density, mass, specific gravity or relative density, specific volume, time, period, frequency. Then distance, displacement, speed, velocity, velocity gradient, acceleration or acceleration due to gravity, momentum, force, force constant or spring constant, impulse. In the dimension column you will be finding out the dimension, and there are some formulae and their units also in this column. So it is a ready reckoner for you. Work, energy, energy density, power, pressure, pressure head, gravitational potential, universal gravitational constant. This value, this dimension you may remember, m to the power minus l cubed t to the power minus 2, and intensity of gravitational field. This is also known as the acceleration due to gravity. Later on we will come to know. Angle, angular displacement, these both are dimensionless quantity. Angular impulse is torque into time, angular velocity, angular frequency, angular momentum, torque, moment of force. Torque and moment of force is the same dimension, and that is also the dimension of energy. Moment of inertia, stress, strain, modulus of elasticity, bulk modulus, compressibility, Poisson's ratio, surface tension, surface energy, coefficient of viscosity. This dimension also you can remember, eta is equal to m l to the power minus 1 t to the power minus 2. And heat, temperature, temperature gradient, thermal capacity, water equivalent, specific heat capacity, ratio or specific heat, ratio of specific heats, then and this is Cp by Cv is gamma, is a dimensionless constant. Latent heat, entropy, specific entropy, Joule's constant. These are some of the dimensions: calorific value, coefficient of linear or areal volume expansion. There is coefficient of thermal conductivity, pressure, coefficient of volume, coefficient Boltzmann constant, Stefan's constant, universal gas constant, electric current, so electric dipole moment, electric field, EMF, electric resistance, electric conductance, resistivity or specific resistance, specific conductance or conductivity, electric capacitance, permittivity of free space, magnetic pole strength, magnetic dipole moment, permeability of free space, intensity of magnetization, magnetic field strength, magnetic intensity, magnetic moment density, then magnetic flux, magnetic induction, and inductance of self, coefficient of self-inductance, etc. Now for optics also, luminous flux, refractive index is a dimensionless quantity, illumination or luminance, it is told, decay constant, Planck's constant, and Wind's constant. These are some of the dimensions. So now some exercise for you from the unit number 1, chapter 2. So the first one is from the error. The second one is also from error with some more insight. Then third one is from error. Then this is the conversion of one unit to another unit. Orbital radius of Mars, this one is conversion of one unit to another. Some more questions are there. Physical quantity, that is from error. Then question number 7, order of magnitude and its implication. Then eighth one is the okay, that is equal. You can do it by dimensional method. Number 9, percentage error in the measurement of height, radius. So it is about the percentage error, so error analysis. This last 3 questions are from the dimension, the air bubble one. So you would be using the third method of dimension. So this then you can do speed of sound, that can be the method of homogeneity. Using homogeneity you can find out the question number 11 and question number 12, that is finding a new dimension, that is also from dimensional analysis. Let me wind up the class because this has become a little long and it's longer than I expected, so not going into detail of these questions right now, but you can always ask me during my live class, live session, explaining how to do some more problems like this. Lots of numericals you'll be finding out in my blog, and shortly I'm going to launch a website